So with functions, we talked about what allows a function to have an inverse. And a function only has an inverse if it's a one-to-one correspondence. Well, it turns out that inverse relations are a lot more common. In fact, all relations have inverses, not just ones with certain properties. And that's because we don't have the rules required for functions. So if R is a relation from A to B, then the inverse relation R minus 1 from B to A is defined as follows. For all elements of A and Y of B, if X is related to Y in our relation. So this is another way of defining a pair that belong to a relation. So we can say X related to Y, or we could also say X, Y is in the relation. These are both valid. So we say if X is related to Y, then Y is related to X in our inverse. So this is a pretty straightforward concept. If we have R is, for example, let's just draw some random lines here. Right, we've got this relation. Then the inverse relation is just going to be the opposite. We had an arrow from A1 to B1, so now we have an arrow from B1 to A1. And notice the order does matter, right? These still are arrows. So you need to have arrows. If you just give me lines, that's not going to be good enough. And B3 goes 4. Is that all of them? I think 1, 2, no, I'm missing one. There we go. So this is the inverse of R. We can do another one. Same idea. Here I'm going to have some relations and that. And now I'm going to have in the inverse, I'm just going to go backwards. There we go. That is the inverse relation.